Okay, let's go ahead and get started with today's activity. So, you're going to do a few things. The first thing you're going to do is your lab. So with your lab, you need to create a series circuit, a parallel circuit, and then I want you to create something else that is going to be creative. So you can build another kind of circuit, or if you want to try to build a motor, you can do that. Also electromagnets. What I do ask is that you're very safe and that you make sure that you're using electrical tape to hold things in place. This tape is expensive, so don't waste it, but make sure you're using this to hold wires onto the sides of batteries. Now when you're finished with these things, I want you to grab one of the hard books, these books right here, and you're going to turn to page 494, and between pages 494 and 499, I want you to take notes on those pages. When you're finished taking notes, I want you to go ahead and answer all the questions on page 499. It would be a good idea if you were to write this down in your agenda right now, page 494 through 499. So write that in your agenda so that you know what to do when you are finished. Again, today, as you're working with the materials, make sure that you're very safe by using the electrical tape first, but also make sure that you take care of these materials because I need to use them for other classes and we want to use them in the future. Be very careful with the bulbs if you're going to use those. Make sure that you don't break those and that everything gets returned back to its original location and that you take very good care of it. Looking at what a diagram for this is going to look like, here you have an example of a series circuit. You have your voltage, you have your load, which is the bulb. We call them lamps, that's a technical name for them. So when you draw the diagram, the small line that you see right here, this is the negative end of the battery. This is the negative. Remember, that's where the electricity comes from. Here I have a circle with an X in the middle. That's going to be the load, or the lamp, or whatever it is you're going to power. And so you can see here, this is the circuit, and then this represents the diagram that goes along with the circuit. It really is that simple. So here's another example. Here is where I wanted to include a switch. You might want to include a switch in your circuit, and if you do, you have that right here as an example. It's just a line that kind of opens up. That's it. All right. Again, you have the circle with the X in it. That's going to be your lamp or light. Now this one, pretty much the same thing I just had, but I added another section to it. And you can see this is going to be a parallel circuit. How do I know that? For a couple reasons, actually. If I make the same thing and I have two lights, so going back to this, if I have two lights side by side in this circuit, every time I add a light, it's going to get a little bit dimmer. However, in this one, that will not happen because the resistance is not shared. It's on each circuit, so the current is actually going to be a little bit higher. And then the third thing you do, and again, I do want you to have that diagram, but the third thing you do, you can do whatever you want. You can build an electromagnet, you can build another circuit with more switches or more lamps. You can try to build a motor. You can try to include a resistor in your circuit. So a resistor, all this will do is provide additional resistance so that your current goes down. So maybe, you know, if you build a series circuit with just one bulb and then you add a resistor to it, maybe that bulb will be very dim. I don't know. I want you to find out though. So again, whatever you decide to do with your third option, totally up to you. But remember, be safe and take care of the materials. Those are my two rules. There's no writing for this lab. All I want to see are those diagrams. That's it.